everyone, welcome back. Today we're going to be reviewing a 6th grade standard, 6.ns.b3, fluently add, subtract, multiply, and divide multi-digit decimals using the standard algorithm for each operation. So the first operations we're going to look at are addition and subtraction. So whenever you are adding or subtracting decimals, you want to line up your decimal point. Okay, so if you notice here, the 2 points are carefully lined up so that the other digits are lined up along the corresponding digit as well. Now here we have an open spot because we have 2 digits here in the decimal and 3 here. So we can actually go ahead and insert a 0 as a placeholder. Now once you've done that, you're going to add or subtract from left to right, just like you normally would. So 0 plus 9 is 9, 2 plus 5 is 7, 1 plus 2 is 3, 7 plus 4 is 11. Now the decimal point falls directly between the 11 and the 3, so we want to bring that down so that it lines up perfectly with the 2 existing decimal points already. So for a final answer of 11.379. Now, if you want to see if you are correct, take a look at your whole numbers, right? So 7 plus 4. 7 plus 4 is 11, so we know that our answer is about the correct ballpark, okay? So that's how you would work out just adding or subtracting. Now, if you find it challenging to line up your decimals on your own, you could create this graphic organizer. What this does is it just pretty much helps you to line up those numbers. So for the first example, we're going to add 73.875 plus 127.23. So let's go ahead and write these in, and we're going to line them up perfectly. Okay, now here in the second one, I have 2 decimal points versus the 3 in the previous. So I have to make sure that I account for that. So I'm going to write that 23 under these 2. Okay, that's really important. Now we can go ahead and actually add. So I'm going to put in a 0 here as my placeholder. 5 plus 0 is 5. 7 plus 3 is 10. 8 plus 2 is 10, plus 1 is 11. Bring down that decimal point. Okay, there was a 1 I needed to carry, right? 8 plus 2, yep. 7 plus 3 is 10, plus 1 again. 7 plus 2 is 9, plus 1 is 10. For a final answer of 201.105. So you want to make sure that all your numbers are lined up, and you can perform a check. 5 plus 0 is 5. This is 10, carry the 1. This is 10, carry the 1, right? So on and so forth. Now for subtraction, the order definitely matters, okay? For addition, I could have opted to put the 127 first and then the 73 afterwards. And when you're checking, you can estimate. So 73.8 is really about 74. 74 plus 127 would have given you 201. Now let's go ahead and take a look at the next example. So here I have 3 decimal points in my second number and 2 in my first. So I want to take account for that. So I'm going to start writing here. Okay, and then that will give me enough space to fit in those decimal points for the second one. So now I'm going to go ahead and subtract, but before I do, I want to put in that placeholder. Now I cannot subtract 5 from 0, so I'm going to borrow. Okay, 10 minus 5 is 5, 7 minus 2 is 5, 9 minus 7 is 2. Bring down that decimal point. Now I'm going to borrow here again. Okay, 12 minus 4 is 8, 5 minus 2 is 3. So if I wanted to estimate, I could estimate the first number as 63 and the second number as 25. 63 minus 25 is 38. So that would help to make sure that my answer is in the correct range. Okay, so this is something that you can do for yourself. You can draw these boxes or you can use lines to ensure that you're lining up your digits. Now let's take a look at multiplying decimals. Whenever you're multiplying decimals, you can actually stack your numbers and pretend like the decimals do not exist. So we're going to look at 5.6 as 56 and 7.2 as 72. Now let's go ahead and do our multiplication. So 2 times 6 is 12. 2 times 5 is 10 plus 1 is 11. 7 times 6 is 42. Bring the 4. 7 times 5 is 35 plus 4 is 9. And then now we're going to add 2 plus 0 is 2, 1 plus 2 is 3. That's 10, and then 4. Now we have to account for the decimal places. So here behind the decimal, I have one digit here and I have another digit here. So I have 1, 2 digits. So what that means is that in my answer, I need to move from the last digit 2 places. So here I go 1, 2. So my answer is 40.32. And this will always work for multiplication. So let's go ahead and try 2 more examples. So again, I'm going to stack my numbers without my decimal point, and then I'm going to account for them afterwards. 1 times 3 is 3, 1 times 6 is 6, 1 times 4 is 4. 3 times 3 is 9, 3 times 6 is 18, 3 4 is 12, and 1 is 13. Now let's go ahead and add. 3 plus 0 is 3, 6 plus 9 is 15, 4 plus 8 is 12, and 1 is 13. 3 plus 1 is 4, and we bring down that 1. Now I have to account for the number of digits I have after my decimal place. So here I have 1, 2, and then there's a third one here. So what that means is in my answer, I need to move my decimal 3 places. 1, 2, 3. For a final answer of 14.353. Now, if we're estimating, right, we can say that this is really about 5. 5 times 3 is 15. It is pretty close to it, right? 4 times 3 is 12. So we know that our answer would need to fall somewhere between 12 and 15. Now let's go ahead and take a look at the second example. So here I have, if I think about this as whole numbers, I have a 2-digit number here and a 3-digit number here. When we know about the commutative property is that when it comes down to addition and multiplication, the order does not matter. So I can actually rewrite this as 6.28 times 0.25. Okay, and that's exactly what I'm going to do because I want my bigger number on top and my smaller on the bottom. So 628 times 25. Okay, 5 times 8 is 40. 5 times 2 is 10. Plus 4 is 14. 5 times 6 is 30. Plus 1 is 31. Now 2 times 8 is 16. 2 times 2 is 4. Plus 1 is 5. And then 2 times 6 is 12. Okay, this is a good place that you can change colors. You know, you have those colored pencils or markers or whatever it may be to help you keep track of the numbers you're carrying over. 0 plus 0 is 0. 4 plus 6 is 10. 5 plus 1 is 6 plus 1 is 7. 3 plus 2 is 5. And then you carry down the 1. Now I have how many digits here? I have 1, 2 digits, and then I have 3, 4 digits. So what that means is in my answer, I need to move 4 digits to the left. 1, 2, 3, 4. So here my final answer is 1.57. I don't need to rewrite all those zeros. You can if you want to, depending on the number of decimal places you need to represent your answer. But those are really just space fillers. They pretty much, this is the same value of this. Now let's take a look at division. We're going to take a look at division in 2 ways. We're going to look at where our divisor is a whole number, and we're going to look at examples where our divisor is also a decimal. Okay, so it's really important to identify the different parts. So we have our dividend, which is inside the house. We have our divisor, which is on the outside, and our quotient, which is our answer. So let's take a look at the steps. Place the decimal point in the quotient. So you want to place it exactly above where the decimal point is in your dividend. Then divide as you would with whole numbers. Continue adding zeros to the remainder, and continue adding zeros to the remainder and dividing until there is no remainder left. Now let's see what this looks like. So we're going to go ahead and draw the house. Okay. Now inside the house, I'm going to put my dividend, which is 59.64. And then outside the house, I'm going to put my divisor, which is 7. Now the step said to put the decimal point directly above where it is in the dividend. So if it's here, I'm going to put it directly on top of it. Now I'm going to divide like I normally would. So 7 does not go into 5, however, it does go into 59. So 7 does not go into 5, however, it does go into 59. This is where it really comes in handy to know your multiplication table. So 7 times 7 is 49, right? So I can go up one more. 7 times 8 is 56. So here it does not go into 5, but it does go into 59 8 times. And 8 times 7 is 56. So I'm going to subtract. That's going to give me a 3, and I'm going to bring down my 6. I do not need to worry about the decimal point, bringing it down or anything, because it's already represented in my quotient. 7 does go into 35. It goes in 5 times. 5 times 7 is 35. Remainder 1, and I bring down my 4. 7 into 14 goes twice, and I have no remainder left. So here my answer is 8.52. So 59.64 divided by 7 is equal to 8.52. All right, let's go ahead and take a look at the next example. So I'm going to put my dividend inside the house, 4.38, and my divisor on the outside. Now I'm going to put my decimal point exactly above where it is in the dividend inside the quotient. Now 12 does not go into 4, so I'm just going to put a 0 there as a placeholder. However, it does go into 43. 12 goes into 43 3 times. 3 times 12 is 36. Okay, and then we subtract. 43 minus 36 is 7. And then we can bring down the 8. 12 goes into 78 6 times, right? 12 times 5 is 60. And then I add one more to that, that's 72. So 12 times 6 is 72. 78 minus 72 is a remainder of 6. Now here there's a remainder, but I ran out of digits in my dividend. So what I do here is I'm going to add a 0, and I'll continue adding zeros anytime I have a remainder till I have none left. 12 goes into 65 times. 12 times 5 is 60. So here I have no remainder left. So my answer for this question is 0.365. Now we're looking at dividing decimals by decimals. Here I like to talk about monkey see, monkey do. So make the divisor a whole number by moving the decimal to the right as many places as it takes to make it a whole number. And then you want to do the same thing to the dividend. So whatever you saw in step 1, whatever you did in step 1, the number of places you moved, then you want to do the same thing in step 2. So monkey see, monkey do. Place the decimal point in the quotient above the decimal point in the dividend and divide as you would in our previous examples. So here we have some shifted in our examples. So I'm just going to go ahead and rewrite them. So I'm going to put an X through that. Don't worry about it. So 0.72 divided by 0.06. And then 12.64 divided by 0.2. So let's go ahead and attempt this problem. So we're going to draw our house. And we're going to just put our numbers in their respective places. So 0.72 goes on the inside and 0.06 goes on the outside. Now here, I want to convert my divisor to a whole number. In order to make my divisor a whole number, I need to move my decimal 2 places. So 1, 2 would make it a whole number. Monkey see, monkey do. So whatever I did out here, I also have to do the same thing in here. So I moved 2 places here. I'm also going to move 2 places here. Now I can rewrite this as 72 divided by 6. 6 goes into 7 once. 1 times 6 is 6. We subtract. 7 minus 6 is 1. Bring down the 2. 6 goes into 12 twice. 2 times 6 is 12. And there is no remainder. So 0.72 divided by 0.06 is equal to 12. Here we don't need to put it in decimal places back in. Pretty much what we just did was to multiply each of these numbers by 100. So you've learned before that multiplying by tens, hundreds, thousands, so on and so forth can convert your numbers, right? So if I multiply this number by 100, I also have to multiply this number by 100. And that will ensure that it does not change the integrity of the problem that I'm working with. If I multiply this by 10 and I multiply this by 10, I'm working with the same values in numbers. Let's go ahead and take a look at this example. So we're going to do the same thing. We're going to draw the house and we're going to put them in their correct places. So this is 0.2, not 0.02. Now here, the same thing. I want to make this 0.2 a whole number. So I'm going to move 1 decimal place, which is like multiplying by 10. So if I move 1 here, monkey see, monkey do. I'm going to do the exact same thing on the inside. So now I can rewrite this as 126.4 divided by 2. So here I literally, anything I do to the outside, I must do to the inside to ensure that I do not change the integrity of the problem. 2 cannot go into 1, but it can go into 12 6 times. 2 times 6 is 12. Okay, and don't mind me, I do have a decimal point here. So before I even started dividing, that decimal point should have been brought up to the top. Okay, so forgive me for that. 2 goes into 6 3 times. 3 times 2 is 6. Okay, and I bring down my 4. 2 goes into 4 twice. So here the final answer of 12.64 divided by 0.2 is 63.2. I hope this review was helpful. Thank you for watching and have a great day.